Welcome to myprojectbazaar.com. Let's discuss about the product. Our product takes a new framework based on recurrence quantification analysis for epileptic seizure detection. This product represents applying recurrence quantification analysis, that is RQA, on EEG recording and their subbands. The subbands are delta, theta, alpha, beta and gamma for epileptic seizure detection. RQA is adopted since it does not require assumption about stationarity. Length of signal and noises also does not require assumption. The decomposition of the original EEG into 5 constituent subbands helps better identification of the dynamic system of EEG signals. This leads to better classification of the database into 3 groups. The classification groups are such as healthy subject, epileptic subjects during a seizure-free interval, that is interictal, and epileptic subjects during a seizure course, that is ictal. These 3 are the classes which we are going to classify. The proposed algorithm is applied into epileptic EEG dataset provided by Dr. R. Andrich Jack of the Epileptic Center, University of Bonn. Epilepsy is a common neurological disorder characterized by recurrent unproven seizure that affects nearly 1% of the general population. Sudden and abrupt seizures that causes momentarily lapses of consciousness can have significant impact of the daily life of sufferers. Thus, epileptic seizure detection would help these people to have a normal life, since epilepsy is a condition related to the electric activity of the brain. Electroencephalogram, that is a EEG signal, may help to detect epileptic seizure. Visual inspection of the EEG data has not yet led to detection of characteristics changes preceding seizure onsets, and detection of seizures by visual inspection of the EEG, even by a trained neurologist, is challenging for a variety of reasons, such as excessive presence of myogenic artifacts. C. Visual inspection of the EEG data has not yet led to detection of all characterized changes preceding seizure onsets, and detection of seizures by visual inspection of the EEG, even by the trained neurologist, is challenging for a variety of reasons, such as excessive presence. Hence, over the years, many researchers have adopted the automatic analysis of EEG to recognize epileptic from characterized. The field of seizure identification has been around for many years, and many techniques have been refined to accurately identify either focal or generalized seizures. This is the flow design which states in about our proposed enhancement system. So initially the EEG dataset is taken in from the input, and which is applied as an input to the process. So initially given EEG signal is processed, that is called pre-processing. In the pre-processing, the decomposition is performed. So during the pre-process, the noises are removed, and then this is signal decomposition. In signal decomposition, the signals are split into 5, that is such as called alpha, beta and etc. They were decomposed into 5, and then it is reconstructed, the 5 decomposed signals. By this we can get accurate values for each signal, which is for the classification. And finally they are reconstructed. After the RQA process, we are obtaining the future values, that is called a future extraction, and then from the values of the extracted result, we are classifying whether it is normal or affected, such as the classifications. Let's see the demonstration of our product. So our product is developed based on MATLAB programming language. Hence we are using MATLAB 2013A version for the implementation. So this is the main panel of MATLAB 2018 version. So this is the main panel, and these are the current directory files. These all are our backup files from our product, and depends on the selected files, the details will be displayed here. So this is the workspace which stores the MATLAB file values which is processed as a temporary values. So here is the main command window. So the main1.m and main1.figure, you can see this is in the same name because this is the corresponding guy file. So while you are running main1.m, it recalls the main1.figure, that is a guy frame. So let's see, I am selecting the run main1.m, it recalls the main1.figure, that is a guy design. That's the main frame of our process. See, this is the main frame. So here initially we have to select the EEG signal as input, and tooltip is processed for every push button. While you are going nearby the push button, that will tell what is the process done by this push button. So let's select the input signal. It's redirect to input dataset, and I am selecting a case. So this is the selected EEG signal, and then pre-processing. In pre-processing, signal is to be processed is ready because here we done normalization, and then it is decomposed. So as we already discussed, the decomposition levels are delta, theta, alpha and beta, gamma. So these are the decomposed signals, and we have to reconstruct the decomposed signals. So you can see the difference between recomposed signals and the original. So this is the reconstructed EEG, and let's see the difference between original and processed signal. So by zooming this, you can see the difference between here. So what are the process have been done here? So these blue color lines are processed signal and red colors are original signals. So and then RQA process, I am applying RQA, recurrence plot. So these are the recurrence plots and future points from the final signal, and classifying. I am classifying the signal. The selected signal is a healthy. The persons according to the signal is healthy. So these are the performance results of this. So we have compared with our existing results. So this is all over our process demo. Thank you.